complex numbers. So what is a complex number? When do these really come up? Complex numbers are going to occur whenever we try to take the square root of a negative. So for example, square root of negative 16, right? Well, we know that that's not just negative 4. We can't take the square root of a negative number. It's not a real number. It's going to be an imaginary number. So this is really equal to 4i, where that I means that it's the imaginary part of the number. So what is I? I is just equal to the square root of negative 1. So for that last example, when we have the square root of negative 16, well, we know that this is the same thing as the square root of 16 times the square root of negative 1, which square root of 16 is 4, and the square root of negative 1 is just I. So I is the square root of negative 1. It's going to be an imaginary number. Okay, if we have I squared, however, okay, I squared, well, that's the square root of negative 1 squared. We can obviously see that I squared is going to be equal to negative 1. So I squared is a real number. However, I is an imaginary number. It's the square root of negative 1. So now the standard form of a complex number we're talking about. Complex numbers have a real and an imaginary part. So the standard form is a plus b times I, where this a is just some real number. This is the real part of a complex number. And then this b times I obviously is going to be our imaginary part of that number. So this is the standard form of some complex number, okay, with a real and imaginary part. And then we talk about complex conjugates. Okay, complex conjugates. Well, I know if I have the complex number a plus bi, its complex conjugate is going to be a minus bi. So for example, let's find the complex conjugate of 3 plus 2i. The complex conjugate is just going to be 3 minus 2i. If I had, let's do negative 4i plus 6, well, that's the same as 6 minus 4i. Right, we could rewrite that as 6 minus 4i. Then the complex conjugate is going to be 6 plus 4i. And now the question might be, well, why are complex conjugates important? Why do they exist? Well, let's see what happens when we multiply two complex conjugates together. So going back to that last example, we have 6 minus 4i and 6 plus 4i. Let's multiply these together and see what happens. And this is going to really show us why complex conjugates are important. 6 times 6 gives me 36. 6 times 4i gives me 24i. Negative 4i times 6, 6 times 4i gives me positive 24i. And then that negative 4i times 6 gives me negative 24i. And then lastly, negative 4i times positive 4i is negative 16i squared. Well, 24i and negative 24i will cancel out when we combine like terms. And then we know, negative 16i squared. I know I squared is just negative 1, so that's negative 16 times negative 1, which is the same thing as positive 16. So I get 36 plus 16, which is 52. So when you multiply two complex conjugates together, you are going to get just a real number. All right, you get a real number, which is very cool, and it's really important, and we're going to see that in 2 slides. All right, let's just do one more example where we're multiplying two complex numbers together. For these ones, we can obviously see that they are not complex conjugates. All right, so we're not going to have a real number as an answer, but that's okay. We can just write our answer in standard form of another complex number. So we have 24 plus 8i minus 18i minus 6i squared. Well, minus 6i squared, that's negative 6 times a negative 1, so that's just plus 6. So I have 24 plus 8i minus 18i plus 6. And then I'll just combine like terms. 24 plus 6 is 30. 8i minus 18i is negative 10i. So this here is the result of multiplying 4 minus 3i times 6 plus 2i. It's just 30 minus 10i. All right, we're going to simplify one more expression. Here we are dividing complex numbers. So it might look confusing. What are we going to do? Do I just put I over 4i and negative 3 over 2? Well, no, you're not allowed to do that, right? Whenever you have addition in the denominator, you can't just split it up, right? We are going to need to do something different here, right? How could we simplify this? Well, we want to have a real denominator. That's our goal, is to have a real denominator. So what can we do? Let's multiply by the complex conjugate. Okay, we're going to multiply the denominator by its complex conjugate. Because I know if I do that, I'll wind up with a real number in my denominator. All right, and obviously anything you do to the denominator, you must do to the numerator. So I'll multiply that by 2 minus 4i as well. All right, let's start with the denominator just because we know that's going to be the real part. So we get 4 minus 8i plus 8i. Good, we did it right. Those are going to cancel. And then minus 16i squared, which we know is just plus 16. Right, these cancel. That's just 4 plus 16. So my denominator is going to be 20. Let's do the numerator now. That's 2i minus 4i squared minus 6, and then plus 12i. All right, we'll take that down a level. So 2i plus 12i is 14i. And then negative 4i squared is positive 4 minus 6. So 4 minus 6 gives me a negative 2. And then in my denominator, 4 plus 16 is 20. So now I have negative 2 plus 14i over 20. And that's just going to be negative 2 over 20 is negative 1/10. And then plus 14 over 20, that's 7/10 I. So this is my, when you do the division, this is my answer as a complex number in standard form. If you left it as negative 1 plus 7i divided by 10, that would also be okay. So if you had it as negative 1 plus 7i divided by 10, that is also okay, right? Those are the same things. We just want to take this term right here and simplify it if we can, right? Divide everything by 2. Divide everything by 2. Or we can split it up, because now we have just a real number in the denominator. There's no addition or anything in the denominator, so we can split up the numerator.